So today I want to review something that I think a lot of you need a little refresher on, and that's going to be on exponent properties. So to start off with, I'm going to give you all the properties of exponents. So, the rules and then an example of that rule. Okay, so I'm going to make this little chart where I'm going to have rules on one side. And then an example on the other side. So the first rule that we're going to talk about is the multiplication rule. And the multiplication rule with exponents looks something like x to the m times x to the n, where you're multiplying. Well, when you're multiplying with exponents, you are going to use addition, which means you're going to be adding the exponents. So that's going to equal x to the m plus n. So for an example of that, we could have x to the third times x to the fourth, which would be x to the 3 plus 4, or x to the 7th. So that's for multiplication. You add the exponents. The next rule is going to be division, which would look like x to the m over x to the n. And when you have division, you're going to use subtraction, which means you subtract the exponent. So this would be x to the m minus n. So you take the top and you subtract the bottom. As an example, we could have x to the 7th over x to the 5th. And like I just said, you subtract. So it'd be x to the 7 minus 5, which would end up with x squared. We're going to have the power rule, which would look like x to the m to the nth. So we have an exponent raised to another exponent, and when you have that, you're going to use multiplication. Which would be x to the m times n. You multiply on the inside. So as an example, we could have x to the 4th to the 3rd. And like I just said, you're going to multiply 4 times 3, which will be x to the 12th. We're going to have 2 more rules. The first one is going to be the 0 rule, which would be something like x to the 0. And whenever you have x to the 0, that's just 1. The 0 rule, it equals 1. Now I'm going to put a little asterisk here so we remember. And I'm going to write anything to the 0 equals 1. That could be any number. Any number to the 0 is going to equal 1. We could have like 146 to the 0. That's going to equal 1. We could have y to the 0. That's going to equal 1. Anything to the 0 power is going to equal 1. And then our last rule is going to be the negative exponents. And that could look like x to the negative n. Now when you have negatives, you're going to do the reciprocal I apologize, I just spelled that wrong. Give me a second. Reciprocal and make it positive. Now reciprocal means you're going to flip it and you're going to make it positive. So this is like x over 1, x to the negative n over 1. The reciprocal would be x to the m, and then you make it positive like it said. So as an example, x to the negative 7th would be 1 over x to the 7th because you flip it. Another example would be if we have 1 over x to the negative 3rd. Again, we flip it and make it positive. Okay? And those are all our rules for exponents. Okay? Now those are pretty easy to remember. It's when we have to apply them that it gets a little bit hard. Okay? So, let's do an example together where we use all these rules put together. So we could have something like this. Okay, something like that. So, there are a couple ways to do this problem. I'm going to show you 2 different ways, okay? So the first way, okay, so let's rewrite this. Like I said, there's multiple ways, so I'm going to show you 2 different ways. This way, I'm going to start by taking care of this exponent out here. Now, if we remember, that's our power rule. That gets multiplied, okay? But you have to be careful because it gets multiplied to everything on the inside. So it goes like this. So that's going to be 2 to the negative 3rd, x to the negative 3rd, y squared, and then we're going to rewrite everything else, okay? Now, my brain can only do certain problems at a time. So I like to think about this as 3 different problems. I have numbers, I have x's, and then I have y's, okay? So, I don't have anything else with the 2, so I'm just going to write 2 to the negative 3rd. Now, from our rules, when we have division, we subtract the exponents. So that'll be x to the negative 3rd, and then we're going to subtract negative 2. And then we have the y's, and again we're going to subtract, because it's division, 2 minus 1. So that's going to be 2 to the negative 3rd. Right here, this becomes a positive, so negative 3 plus 2 is 1 y to the 1st. Again, going to our rules, negative exponents. We have a negative exponent, that means flip it. So that'll be, we have x to the 1st, y to the 1st, over 2, we make it positive. And then all we have to do is take care of that 2 to the 3rd now, and we get x, y over 8. Okay? So that's one way to solve this. Another way to solve it is to take care of all the negative exponents first. Okay? So what that will look like is, I'm just going to do it right here. I see that this is a negative exponent. So I'm going to put it in the denominator. So I'm going to make my thing, and I'm going to have 2x to the 3rd, excuse me, in the denominator. I have this negative exponent, so I'm going to put it in the numerator now, and then those stay the same. From there, you do the same process. You take care of this 3, so that's going to be x squared, y squared, over 2 cubed x cubed y. And then, like I said, I like to separate it into 3 problems. You should get the same answer once you do that. So hopefully that'll help when you're trying to do exponent problems. We will be practicing this more.